So good evening. There were more people yesterday, if I remember correctly, but communication is hard. It's not on the planning, so we have a few less people tonight, at least. We will be able to explain correctly something that I started to explain yesterday. We didn't have enough time to see all the real solution. We will have time to show the code, because most of you will be interested with code. And we will have some time after that to discuss the solution that I implemented, because I know some of you have implemented things like that on their side, so we can discuss of your solution and how we can put all that together to get a better solution that could be possibly integrated into Qt later. So we will go quite fast on the first slides because you already saw them yesterday. Just no? Who wasn't there yesterday? Oh, okay. So that's not really a reminder session. It's a new session for you. Okay, so we will talk about several points. The first one will be a quick reminder about application that mix C++ and QML, because there are some rules that you must respect and some issues that you want to know and to care about. Then we will have some reminder about the model view controller in Qt, not especially in QML, in Qt in general. Then we'll see some different kinds of models that you can use for Qt Quick, because there are so many ways to create models for repeater or list view in Qt Quick, but they are not equal. Some are good models, that are not really models and have really bad performance. We'll see all that kind of stuff just after. We will see the good old way to create models in Qt, in C++. Then we will imagine a perfect solution that would be simple, easy to use, and that could fit everyone. Then I will talk about my specific implementation based on some tricks with templates and meta-object. And after that, we have a quick topic about simplifying another side of the model itself. Not really the model, but what goes around the model, because that needs simplification too. And after that, in the last section, we can discuss about all that stuff, and you can ask me questions. I can show you the code. I can show you examples of this model. So first, if you have done C++ and QML apps before, you know that you have to respect the logic and UI separation. Basically, you use C++ for the business logic and the QML for the visual interface. And you can use JavaScript to integrate both, because in some imperative code in QML, you are using JavaScript syntax to call C++ methods. You can also have object shared between the two languages, so you can have C++ instance that can be exposed to QML using a context property that creates a kind of global variable that you can access from anywhere in your QML. And you can also have register components, so that's a class, a QObject class, that can be directly instantiated in QML, like regular components, let's say a rectangle or text or image. But if you want to have a good performance, you have to avoid needless conversions. So you don't want to create something in one kind of type that will be often converted between QML and JavaScript and C++, because that adds a lot of overhead and performances get terrible. As long as you're using model view, you want to have dynamic view. So if one item in your model changes, you don't want the whole view to be reloaded each time, because that's terribly slow. And you want globally to avoid using JavaScript if you can. That's the hints that was given by many people, many speakers at this Congress. So I will say the same: avoid using JavaScript if you're not forced to do it. JavaScript should be reserved only for bindings and a small line of code in signal handler to call C++ behind. You should not have a great algorithm and loops and conditions in the JavaScript. You must know the limitation of each tool. So you must know that QML can't access the low level. You can't open files or use socket directly in QML. C++ on its side have a very powerful classes for models, for lists, for hash table, for many things. You have also powerful algorithm that you can use in Qt, in the C++. But in the other side, the JavaScript syntax is really simpler. You don't have to care about types. You don't care about pointers. You have less cryptic symbols in the syntax. So you want to use JavaScript for simple things. And QtQuick is the best tool for visual delegates to create lists with nice animations, easily stylable, and you can do really nice user interface with QtQuick. So you don't want to do the visual interface in C++. So you must know the limitation of each tool and use the one that is the most powerful for a specific point. So for the model, that is what is interesting us tonight. The C++ is really the best tool, but also the most complex tool. So the aim of this talk is to simplify the C++ code so that it can be as simple as the QML one. So usually, if you define models in Qt, you are using QAbstractListModel or QAbstractItem model. And they are all using a base node that is called QModelIndex. A QModelIndex has basically a parent or not if it's a one-dimension list. You have a row in your parent. You are the 6th element or the 10th element, and you can have columns for each row. But above this model index, you also have the roles. A role is basically an information of a node. You have maybe text data, but you can have text color, text size, maybe selection, some kinds of information around this node. Each node can have an infinity of information on it. And in the QML side, you don't know about the role directly because in Qt, the roles are simply ints, enums, and QML use strings because it's simpler. You don't have to know if you are using role 6 or 4 or 10. You are using the role name or the role size. That's really simpler. So you have to have the matching between these role names and the role int. We'll see that later. You have also in Qt the ability to use proxy models. So you can have one model and several views using the same model with different formatting, different filtering. Let's say, for example, you have a contact list and you want to display in one view the girls, in another view the men. You can, using the same model, filter on one property, and I have several views sharing the same data. That can also be used to change the structure of your model. For example, using a tree model and put it back to a flat model, or the opposite. And one thing that is really important with the Qt models is that it informs the UI of the changes atomically. Because before changing something to the model, you are informing the UI that something is about to change, and after you did the actual change, you can inform the UI that it has changed, so it can reload specifically what has changed and not the rest. So, QtQuick has several types of model that can be used, but they are not really the same, and they are not models necessarily. The first one, it's a QtQuick list model. So when you're typing in the QML code ListModel brackets, it creates an object in which you can put list elements, but these list elements are really limited because you can use only 3 types. You can use only ints, strings, and bools. You can have complex types. You must also use only literal constants. You can't have bindings. You can't have script. So you can't even call QSTR on the strings to get them translatable because QML will tell you that it's not a constant. So you are really limited with this model. That's really cool for simple things, but it's not a powerful model. You also have the JavaScript array of objects. So in JavaScript, you can use the JSON syntax to create an array with objects in it, and each object can be an item for a list, for this view. But it has two problems. First, it's only static because some change in the model will not be notified to the UI, and it's weakly typed because it's JavaScript, so you can put anything in there. QML won't notice that it's some type or some other type. You have to check all the model in the delegate to be sure what you are using. You are using duck typing, and you are assuming the model contains this or that, but you can be sure. Most of you may have used the QList of QObject because that's quite handy, quite simple. You put some custom object in a QList and you give the QList to QML, and QML is able to display it, but it's strongly typed. Your model is robust, but any change on the model must be reloaded. So if you append one item at the end of a list with 100 items, you will have the 100 items plus your new item reloaded. So that's really not performant, and that's not dynamic. So you should avoid that at all price. But I agree, it's the simplest model that you can create in C++ for QML. You may also have used the QQmlListProperty, because I saw some posts on Stack Overflow, people asking, I want to create a model for QML, what class should I use? And some people who have not read the documentation answer, use QQmlListProperty. That's totally wrong, that is not a model. Be clear about that. QMlListProperty is only meant when you create a custom component in C++ for QML, when you want to be able in QML to instantiate a certain object in it. For example, if you have a contact and you want to have object information in it, you can have a QMlListProperty of information in your contact so that in QML you can instantiate information in your contact. That is not made to create a dynamic model or something that can be append, remove, prepend, filtered, etc. Also, the API is horrible. You have to implement some static methods and use pointers to the calling object. That's really not object-oriented at all. So avoid using it unless you are forced to have object instantiable in QML and that can be registered in another object. And you finally have the C++ QAbstractListModels subclass. That is the right way to do it. That is also the most complex way to do it. You have some methods to re-implement, some functions to call to inform the UI. We will see all that. Just a quick reminder, if you have found a nice and fancy way to create a model, but if your model doesn't inform the UI of the addition or deletion of items, that is not a good model. You could lose your scrolling position when the model gets reloaded. You can lose the selection of the user. And of course, it's heavy. If your model can't notify when a specific value in an item is changed, that's also not a good model, because change can happen in the backend and the frontend won't be informed. So in the UI, you will see nothing change. And finally, if your model can be easily manipulated to add or remove items, that is not a good model, because a model will need to be modified often and easily. So you can do it with the same technique as you used on the QtWidget era. You are using the QAbstractListModel, and you are re-implementing a certain amount of methods. The strict minimum being the data, send data, and role names methods. That's really the list you can re-implement. There are tons of others. You have to call set data is not really needed if you want a read-only model, yes. And you have to call in your specific implementation where you are implementing, for example, the append API, you have to call begin insert row and end insert row in your method so that the UI can update. So if you forgot to do it or you put the wrong parameters in it, it doesn't work. And you can spend a lot of time trying to figure out what is not working. So you have to declare yourself a lot of API to add your items in the model, to remove items from the model, etc., 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 depending on what you're trying to do with your model. And you're finally using some storage inside that is always almost the same, some QList or QVector of a class or a struct. Basically, you are very often doing the same. And one class of QAbstractListModel must be created for each kind of model. So if you have a model with contacts, model with, I would say, appointments, model with documents, you have 3 different classes that you must implement differently with 80% of the code being the same. So the ideal solution would be to have the same API as the QList because it's simple, everyone knows it, everyone uses it. And it's quite good, quite well documented in the Qt documentation. And it would be consistent with the list. We would also love to have the role names created automatically, because finally, roles in a model or properties in an object are basically the same. You have a name, you have a type, it can be mapped to the Q variant, so that's really close. Why not use them for the same thing? And we have more similarities because a Q property can be readable or read-only, or read-write, or constant. And the same goes for a role in a model. Not all the roles are readable. So why not map the setData and data methods to the setProperty and property methods of the Q object? And more, a property in Qt can be modified, and when it's modified, it emits a signal so that the UI can know that it's modified and update itself. And in the model, we have just the same behavior, except that it's using a single signal that is non-data change, and this signal has parameters to know which role has changed. So we could simply forward the property signals to a simple model signal. And finally, if we want something simple, one line, we should have simply a template-based constructor, just like QList or QVector, and not having to subclass QAbstractListModel anymore. Everyone is agree with that. That would be a simple solution, easy to use. So I had the same issue for years and years, so I did it. I found a solution to avoid reimplementing and reimplementing QAbstractListModel again and again and again. And I tried to make it as simple as possible so that the C++ side is not filled with some glue code that is uninteresting, error-prone, and I can focus on the business and on the UI. So I have created a QQmlObject model. The name is quite long. Simply, that means what it is. It is a model that is created from a list of objects for QML. So that's nothing to do with a list property or a QList or something else. That's a new kind of class. That's a model made of objects for QML. It's really easy to use. It's just like QList, a template class. You need only one line in the C++ to create a model. You have nothing to subclass. I have already used it in a lot of projects, and some of my customers have used it also, and I've tested it, and it's quite used now. It's open source, so you can use it in your project, and I would note that there is no license on it. You don't have to care about GPL, LGPL, MIT. The only license that could go near it, so what I want is the WTF license. So do whatever you want with it, I don't care. You can use in commercial project or open source project or no project or whatever you want. And if you are a good guy, you could contribute patch, but if you don't want, I don't care. I won't sue you. Don't worry. So, in addition to this already nice features, it has some extra features, like, for example, indexing items using a primary key. Often, when you're using a SQL backend, you have in your table some column that is a primary key. So each entry can be identified using this entry instead of using a position in the list. That's really useful. That's more robust. So you can use that in the model. You just have to declare this property is my primary key, and the model will index items internally, so you can query them later using the UID instead of using the index. You also have a special QtObject role that can be used to query the object itself, not the property, the object. So you can call a method or connect to a signal if you have any. It can be useful also. And if you have a really simple use case and you don't want to use a QObject-based model and you don't want to have an object with only one role, for example, you can use the QQml variant list model. That's the exact same concept, only that each item is not a QObject but a QVariant, and you put what you want in it, some int, some string, and you have only one role, QtVariant, and you access your data. That will be still far, far, far better than using a QVariant list, because QVariant list has the same issues as the QList of QObject. It's really lightweight also. It doesn't have much overhead compared to a QVariant list, maybe less. So I will show you an example of use of this just after, but I have to show you first another aspect of this model. I said that I'm using a QObject class to create the model, to extract the information to create a model. So each item in the model is a QObject. So I needed to have a simple definition for QObject. When you are creating a new component in QML, you just declare property, type, name, default value. That's quite straightforward, simple, understandable. So that's really cool. In the C++ side, when you want to create a property, you have a lot of code to write. If you want to do it well, you need a class member, so one line in the .h and one line in the .cpp. You have a getter method, declaration in .h, 3 lines average in the CPP, a setter method that will check the value, so you have an if condition and an emission for the signal, so that takes 5 or 6 lines in the CPP. You have also the notify signal that you must declare in the .h, and you finally have a QProperty macro that you must write yourself in the .h and give it the name, the type, the getter, the setter, etc., etc. So in total, it takes at least 20 lines to create one property. And if you have 10 properties, do the computation yourself, it grows, and it grows again, and your code is spammed with glue code. That has no interest, there is no logic, no intelligence, so that's pure loss. So in QML, in opposition, you only need one line to create the same content, the exact same behavior, because all the getter, setter, and notify stuff is hidden in the engine itself, and declaration and initialization in the same line, in same place. In C++, except if we are using C++11, you can't initialize the data in the .h, so at least we'll try to get it on 2 lines. One in C++, one in .h, in the header file. So we should have only one line to declare the property and one line in the C++ to set the value in the constructor. To be able to do that, we need a new macro that will be higher level than the QProperty macro, because it will create all the members, getters, setters, and notifiers, and will also create the property for Qt. And we would have 3 macro for the 3 access mode, one being readable. Readable means C++ and QML can edit the property. Read-only, which means QML can read the property, but only C++ can edit it. And constant, that means it never changes. It's initialized in the constructor, and it will never change. So Starting from that, I will show you a simple example. Here is an example of an application using a model of my item. I don't know what it is at the moment, but I create a model using only one line. Lightem, okay. Yeah, excuse me. Oh, okay, my bad. C++, yeah, c'est le text editor. Default.
If you could make it a bit larger.
A bit larger? Like that. I can try to make it a bit larger. So, as you can see, I'm creating a model on this line with only one line of C++. I'm creating a new QQmlObject model from my item, which is a QObject derived class. And I'm just giving it a parent because it's a QObject, so we need a parent. And there are two optional arguments that you can use. The first one being a display role name. So if you have a role that is the visual content, you can declare it this way. So, for example, if you're using the Qt controls, you can use the model in the combo box and have the data automatically displayed in your combo box. The second one is the famous unique identifier role name. So if you tell, for example, bar is my primary key, it will be used to index all the components in the model. So just under that, I'm filling the model. So I'm creating with a loop, a simple loop, my item instances. I'm setting the value of the item, and I'm just appending it in the model, just like I would do with a simple QList. And finally, the model is exposed to QML using a context property. That's a simple to do for an example. So you want to see the declaration of the my item because it's what matters. I just have this simple file, nothing else. I have QML writable properties with types and names. I have some read-only property, so this one will be set from the C++ and QML could not overwrite it. And I have two constant properties, so the value will be set in the constructor and will never change after that. So that class is really small, you see, 11 to 29, a very few amount of line of code. And the only thing that I have to put myself are the default value for the properties. I'm setting them in the constructor, but I can also have methods in my object, and these methods will be callable from the QML because I have this special QtObject role that can allow me to call the methods if I want. I'm not sure I've used it in this example, but it's doable. So I'm sure that you're really impatient to see the code of the QML object list model. So
can you show the
macro? Oh yes, I can.
Because I tried the same thing. It didn't work.
Okay, I will warn you. That's really ugly. That is a huge macro, but Qt is full of macro anyway. I tried to do it cleanly using templates, and I couldn't get it to work together with the Qt property system. So I simply did a huge and ugly macro. A QML writable property with a type and a name is simply a Q property, a private member, a getter, a setter, and a notifier.
Basically did the same. The Q property definition didn't work.
Yeah, I didn't try it on Qt4. Maybe there was an issue with Qt4.
I think it's a couple of years ago that I
Yeah.
tried it, and maybe they switched it.
So there are similar properties for read-only. There are simply a setter that is not usable from QML because it's not in the slot section. And constant property doesn't have setter and notifier at all. So these are the ugly macro. now I can show you the beautiful class. Beautiful, but template, so quite hard too. So, as you may know, the mock doesn't accept that that you are using a QObject macro with a template class. It just tells you I can do that, and it does nothing. So I had to trick around. I just did a QQmlListProperty base class that is inheriting the QAbstractListModel and using the QObject macro, so that I could declare my QProperty for the count of the model and some slots for the public API, basically the same as a QList. You can find size, is empty, append, prepend, remove, etc., etc. But these slots are all virtual poor because I want to use the implementation in my template class. So, and I have also a signal for my property. So after that, I could create my actual QQmlListProperty using a subclass of this previous class that is a template class that can accept an item type. Item type must be a QObject subclass, because in my constructor, I'm using the static meta object of this class to extract all the needed information to fill the model. So I will extract each property, and for each property, I will extract the name, check if it has signal, and then create some cache internally to handle the signal later. And after that, in my setData or data methods, I can simply use the setProperty or getProperty of my QObject class, because it's some standard Qtype AI. I didn't have to create some switch with the different value of rows. And I have some special handling here. If I'm asking for the base role, so the QtObject role, I'm not returning the property, but the object itself. So the role names is simply returned from the map that I have filled in the constructor using the introspection. I also have declared some iterators for the people who are using the new C++11 4. You can use these iterators. Then we have the implementation of all these methods that I declared in the base class. That's really simple stuff around the internal QList. I simply have some of the needed methods called by Qt. For example, if I'm using append, I have to call internally the begin insert row and the end insert row. And I'm also updating some internal counters and referencing the item. For example, reference item is interesting because that's where I'm connecting the actual object with the model. And I'm also managing the memory at this point. If my item doesn't have a parent, I set myself as a parent. So when the model will be deleted, it will delete the items. But if you put in the model some item that already have a parent, the model considers that the object is managed by someone else and won't delete it. Even if you delete you remove the item from the model, it won't be deleted, destroyed. So that's a quite easy way to handle the memory ownership for this model. And after that, I simply connect all the signals of that object to an internal handler that will simply, when some property changes on an item, will simply check, okay, who changed? So I get the pointer to the item. Then I ask which signal was emitted, so I can use the previously filled hash map to get back which role is attached to this signal. And then I can simply emit the data change signal using a QModel index created from this row index and a vector of ints for the various rows that have changed. So, and if the value of the property that is used for the role name for the unique property has changed, I also update my internal cache so that when your user queries an item using a unique ID, I can get it. I can get the right ID. So, and in fact, in the private section, my model is simply a QList of pointers of QObjects. So, exactly what we were trying to do using a QList of QObjects in QML, simply with a wrapper, dynamic wrapper around it. So that's quite simple to use. Also, if you have an object that you want it to have its own model in it, you can nest model if you want. You can have a property of an item that is a model of another class. So you can perfectly create nested models with that. So you just use QMlObjModel property, and you are creating, in fact, a QMlObjectListModel of your property. So you can do any kind of nested stuff. So we don't have a lot of time, but still I will show you a real-life example. This is a simple lyrics editor. So you can open a song. You can have various groups of lyrics. And each group can contain lines, and each line can contain codes. So we have 4 levels of nesting. And in the C++ code, this is really obvious. Just showing you the .h. Well, I have a code item, which has its properties, and some methods too. I have a line item, which has a property and a model of code item. So I have already 1 level of nesting. Above it, I have a group item, which has a model of line item, and I have a song item, which has a model of group item. So I can easily nest my model and ensure that objects are correctly nested. That I can have, I will not have a line item directly in a song item because the model doesn't allow that. So I can have some type safety at the model level. And in the QML, it will be really easy to use because all the properties are automatically filled. So in the C++ logic, I will simply manipulate my objects without even knowing that it's in a model. I'm using a list, a simple list. And in the QML, I will be able to use a simple model without knowing what is behind. So both of languages have the best possible API to use. On the C++, you use list and pointers. On the QML, you have a model with roles, and it's really simple. So we have just a few minutes for questions. So if you want to see some related code, or you want to talk to me about your own implementation, feel free to do it. Thanks for watching. Yes?
Could you give us a glance at the QML?
You are asking if I could show you how to use this in QML, or
The QML of the lyrics quote.
yeah, that's a quite huge application. So the QML is quite huge too. But what you can see is that, for example, using a repeater using a model groups, so a model of group items. Because in my song item I have a property that model group that is a model of group item. I can use it like any other model in QML, and then in the delegate I can use model.QtObject if I want to call some properties or methods, so what I need to do in my project. But I can also use all the roles that were declared in the group item. So I could use group, for example, which is the name of the group. Or in the case of code, I could use position, type, so model.position, model.type, etc. That's completely transparent for the QML point of view. You just have the same names for the roles that you have for the properties in the C++, and you have one additional role that is named QtObject to get the object itself to call methods or signals. That's completely transparent for you.
Thank you very much.
Someone else? Yeah, I worked with a quite huge project with models of thousands of items. And anyway, before having this model, I was doing quite the same, but manually each time. But if you have a model with dynamic items that you can modify from the C++, you have to watch for the change and inform the QML. So you are doing basically the same, maybe in another way, but you must watch for the signals and call the data change methods and all that kind of stuff. And you are also using internally some QList or QVector of items. Maybe your items are not QtObject, but maybe structs or something else. But finally, I found that using QObject and signals isn't slower than using something else, and it's much easier. I couldn't make my class itself a template because I would have been forced to remove the QObject macro and do all the stuff that Mock does by myself. I didn't want to do that, so I created a base class that is QObject and not a template. So I could use the QObject macro to declare all the slots and the signals and the properties in the meta object. That's why my slots here are virtual pure. And I'm simply re-implementing this in the subclass, which is not QObject because it doesn't have the QObject macro. It just inherits my class to get the macro, all the stuff that Mock generates for this class. I'm simply inheriting the QObject metadata and not recreating it in my subclass. That's a simple trick to be able to create a template class that inherits QObject. And in fact, Qt itself is doing it. You have some objects in Qt that are template and still QObjects. Last one. That's all. Yeah. So, thanks for watching. Oh, anyway, if you want the code, maybe the address is quite long, but you can also take my visit card. There is a link to my website, and on the website there is a list of nice projects, including this one. So the project is named the QML tricks library because it's not just this model. There are some Qt components, some QML controls. There are a lot of interesting stuff in there. So just check out the library and take what interests you instead. It's a kitchen sink library. There are many things put together. That's all the reusable stuff that I'm sharing between my project. There is no consistency about the content, but there are some interesting stuff. Just take what you need and throw the rest.
Thank you very much for this.
Thank you.